luckily I didn't, and I made it back in time. I had to go to emergency to get patched up. Anyway, all good. I see quite a few people joining. Definitely more coming in, and we'll start sharing the video as well. Great. Sorry, that was for me doing the YouTube live. Great. So we might get started. So welcome everyone to a very exciting data futurology episode. Today we'll be speaking with Carlos Abello. Carlos is the Director of Paid Marketing Analytics at eBay. I've been looking forward to speaking with you, Carlos, for quite a while. Your trajectory, your experience is amazing. I saw that you worked in publishing, you've had your own business, you've worked at universities teaching, and you've been at eBay doing extremely interesting things. Obviously, the causal inference, experimentation, customer intelligence, all things that we'll discuss today. I'm really keen to pick your brain on causal inference. Carlos, thank you so much for being on the show. How are you going today?
Great. I am looking forward to this as well. It was funny, right? We had all these arrangements of this session before sabbatical that I took, like 4 weeks time off, and then on the preparation during that time, it was one of my big motivations just to return, is just to have this session the very first week that I was back. So looking forward to it.
That is very kind, very kind. Thank you so much. And how was your time off?
It was surprisingly good, given all circumstances, right, around coronavirus, etc. So I wanted to go to my homeland, which is northwest Spain. It was not that easy, right? So I actually took one of the first flights that were open right after the ban for travel was off at the beginning of July. And I actually came back right when things started to go a little worse again, right, in Europe. So, I had this window of opportunity, right, where I could have fun, and it was amazing time. So you can see the picture in my background. That is sunset in San Sebastian in northern Spain.
Oh man, San Sebastian is amazing. Obviously, like I think every Spaniard that I've ever met has told me, like, you should go to San Sebastian for years, and I only got there I think 2 years ago, and man, I love San Sebastian. All the region. Is it in Asturias?
No, this is the Basque Country.
Basque, of course, yes.
Yeah.
But they're side by side, right?
Yeah, 400 kilometers apart, but yeah.
Yeah, amazing. No, man, that region, the northwest of Spain, I was so impressed. Absolutely loved it. So thank you so much. I'm glad you enjoyed a bit of time off. Thank you so much for making the time for us to have a chat. So to kick things off, can you tell us a little bit about how you ended up working in eBay, working in causal inference, what sparked the passion for you in this area, and tell us a little bit about your journey, and then we'll dive in from there.
Yeah, I think I have a pretty, I don't know, in a sense, a pretty typical or stereotypical journey from people of my generation. So we started with direct response marketing. That was an extremely data-driven, very scientific side of marketing before e-commerce even started, right? And we were tracking all the data from coupons and from all these response coupons. So we had plenty of people just entering all this data, right, into data sets and then analyze it. It was fully data-driven kind of business model, so unique. At that time, we appreciated, things like after that were becoming so important, like quality of data and just trying to capture everything important to business performance out of data. From there, when e-commerce started, then there was a keen interest, right, on poaching people from direct response, because it was kind of, a digital, it was not digital, right? But we have, from a data perspective, a digital data set, avant la lettre, you know, even before we had the internet working, right? So I started that transition. While I was doing the transition, then I got also connected with another side of marketing analytics, which is just TV, particularly TV, measuring impact of TV, which is just the opposite of that. So you don't have that much even today, right? That much ability to track sales that are coming from TV advertising. But still, you have the same need, right, for calculating return on investment, and then just getting into the causal inference, right? How much this thing is actually getting to you as a business. So the approach there was completely different to direct response. And this is where we started, you know, talking about incrementality, all these concepts, right? How to set up tests and experiments just to get to the causality of the sales that you are getting from that. And then all these two work streams, I would say, then converged into eBay, when I started working on eBay, where actually you had all the data in the world, very high quality of data. You don't have to be concerned about that. However, even if you have all that, you know, extent of data and everything is traceable, you have again the problem of incrementality, because many of the traceable marketing contacts that you make are actually not causal. So if we have eBay so well known, right, and we have such a large base of customers, that many of those who actually click on a Facebook ad or on you know, Google search and come to eBay and buy, actually they are not incremental to eBay. They would have come anyways. They just happen to come through some marketing. So how to disentangle that and how to figure out how much incrementality is coming from paid marketing became again, you know, an important theme. And I would say just these large retailers, you know, Amazon, Walmart, eBay, we all have shared this specific problem, right, to us, which is just getting deeper into causal inference. Most of the solutions in the industry are based off attribution. Attribution is not causal. So we just needed to create a new you know, framework for ourselves and tailor to our business needs, which, you know, actually is the main theme, I would say, of my last few years, right, in my professional career.
Yeah, amazing. And for the people that haven't heard of causal inference before, how would you describe it to them?
It's just you know, what is based off some evidence that you collect, how much of an impact a specific marketing impression or a marketing effort, let's call it like that. It could be whatever, right? It could be an impression of an ad. It could be, you know, some radio advertising, whatever it is, the market impression that you're making. What is the impact that it is having on your sales, on your overall sales? Doesn't have to be sales that are coming through any code or through anything specific to the marketing campaign. It's just your overall sales just grow. And so it's just, you know, getting to that, you know, certainty about the causality of it being the specific marketing investment that you have made.
Yeah, and that's awesome, and that's why it's so important for marketing, because again, it gives you more certainty about where the right dollars are being spent. And I've noticed that a lot of, or maybe most, definitely a lot of the people in causal inference or the working causal inference, they come from an economics background. I saw that you have an economics background. Do you agree with that? And if so, why do you think that's the case?
Yeah, I think out of the many, you know, the many tribes that are around data science, I would say, yeah, there are, you know, computer scientists who typically have, you know, it's more about data processes and, creating data pipes and analyzing, deterministic processes, etc. Then you have the tribe, which maybe can be split in two, but statisticians and researchers on the social sciences space, right? And these guys are typically more prone to causality, right? On experimentations, on trying to find causality on multiple fronts, right? It could be on health, could be on education, could be on economic policy, whatever it is ultimately leading to this A/B testing, very old kind of trick, right? From scientists, A/B testing, when you are observing some population exposed to some treatment versus another population not exposed to that treatment, and then you compare the performance of both and infer, what is the causal impact of the treatment. So because I think that is so much core to our academic background, this is why you will find so many epidemiologists, so many economists, of course, econometricians, around these topics.
Yeah, it is very, very exciting. And can you tell us about the journey on the experimentation side that you've had at eBay, and how, if you can tell us a little bit more about how the causal inference part is tied into the experimentation, and then how you went on to scale up the experimentation.
Right.
Yeah.
Great question. Yeah, experimentation is just the core of it. So you cannot get into causal inference if you don't compare two different populations with different treatments, right? So how we do this in marketing is a very special domain. And why is this special? Because if you think about it, marketing is is the product of a partnership, right? A partnership between the advertiser and the advertising platform. So let's call it, Google and eBay, right? So there are two different companies, and there are things that we are ready to share, and some others that are tricky to share, particularly, the customer data and some things that are core to our competitive advantages, and we just don't want to share. Now, if you want to set up a test where you are actually suppressing treatment to some people and allowing others to be exposed to the treatment, and then compare the final results on sales on eBay, in this case, what you need to do is to find out a solution where you are sharing enough information so that we as eBay, we know who has been exposed and who hasn't. So then we can compare the sales. The sales is something that we only us have. And Google actually is effective in making the specific suppressions over this split of customers, right? So this coordination is tricky, right? It's tricky, and it is very, this is, as a matter of fact, I discuss this often. It is something that, unless you have worked in the industry, it's impossible that you get, many people in academia don't get, specialized on that, because you just need to be hands-on, and it is evolving so fast over the course of the years. But just for the audience, right, I think the two main ways to test this are either what we call geo-based or user-based. Geo-based is less demanding in terms of the coordination, but still it requires that both advertiser and platform aligns on some geo, some region that is going to be suppressed from marketing treatment, and then align on which regions are going to be exposed to that. Then that doesn't require any matching of users. It just requires that, the platform is able to target or not target according to geolocation of the user, and the retailer, so the advertiser, is able to split as well the sales according to geolocation. So that's one of the areas. Yeah, for more technical audiences, one of the problems of geo-based testing is just the statistical power. Because, of course, when you are suppressing one geo, you are not just suppressing the people that would have been exposed to marketing but weren't. You are just suppressing that whole geo. So in order for the marketing impact to be surfaced and be noticeable, then you just need an impact which is pretty substantial. Otherwise, it gets diluted on the humongous, audiences that you have, most of which is actually not affected by marketing at all. In order to address that, then what you have is what we call the user-based testing, which is regardless on where the users are located, it's kind of using a magnifying glass, right? So you are just identifying the users that would be targeted. And then out of those users that would be targeted, half of them will be targeted and serve impressions to them, and the other half, they wouldn't. So the whole difference between these two people is just the marketing treatment, and they are not diluted into larger samples of population. So you are just comparing the net sales that these two groups are having. So you don't encounter as many issues with the statistical power. It's just cleaner from that perspective. On the other hand, you have all kinds of other problems because just the precision of the tests, because of the level of coordination that it requires between platform and an advertiser, are great. And we have so many limitations from compliance and from the regulations in every market. You will always have some level of contamination that is actually greater than what we find in geo. So it's more of a one-to-one basis, is half art, half science kind of technique, right? In order to ascertain which is the best experimentation setup for every single case.
That's amazing, and that's so interesting to look at it in that partnership framework, and that any separation of control and treatment group needs to be across the board. That's incredible. And what type of things are you, obviously things that you can share, but what type of things do you experiment on? What type of things do you test?
Right.
What would that be?
Right. So the main thing that we test is just the marketing impression by itself. So let's say, you take search in Google. It's an important part of marketing budgets for all e-commerce. And then what you do is then, well, let me try what happens when I am not investing anything on search. So eBay is out of Google search, let's say, right? So everybody who is searching for whatever, a pen or a notebook, is just not finding anything on search. And then what you get from that is just the return from that marketing investment. And when you calculate the return, then you can calculate the return on investment. So then you can provide to finance and to the marketers in the team the input that they need to figure out whether the level of investment makes sense. Now, there are some variations around that. So at times we test different spend pressures, so different investment levels, how much more we get with the next X, $1 million or whatever it is, the amount that we are investing, right? So at times it is, saturation level or level of pressure that we are testing. Other times it's more about the mix of tactics. So there are multiple types of operations around search, multiple types of bidding practices, or multiple types of creatives around, typically not on search, but on some other platforms. So that is also something that we typically measure. One warning or one comment that I would make to this is that there are things more more impactful to bottom line sales, let's say, than others, right? And the greater the impact, the easier it is to measure causality, of course. So I would say if we have to rank those, of course, spend is a critical factor. So how much you are spending, right? Second critical factor is on anything related to targeting tactics. These are very impactful, of course. If you are suppressing some specific audience versus other, you will have very different results. And then the creatives, what we call the creatives, are typically the things that many marketers prefer because it's the thing that they are actually handle with the most, right? So they are trying to get to that, but I always tell them, well, if we have 100% of impact with everything that we do, probably 5% is around creatives. So you need also to consider that, right, in order to prioritize your pipeline and schedule of testing, because testing is also expensive, of course. And yeah, that's what makes, ultimately what we call the learning agenda, what we want to learn with the amount of experimentation bandwidth that we have. And more often than not, it's on these very critical drivers, right? Not on every kind of hypothesis that we may come up with.
Exactly. And I think the important thing to understand there is that the breadth of, I guess, of the responsibilities of your role and of your team. That you are the marketing messages are not marketing messages that say, hey, come to eBay, or use eBay. It's at a product level, it's at a listing level. Is that right? So you're going very sort of in depth into the different, all the maybe thousands of categories that eBay has. How does that work?
Right. So yeah, that's exactly, I think there are two aspects on everything we do around causal inference. If you think about it, one is just this kind of high level ROI or financial estimation, right, of impacts, which I mean, is important, of course, for many things, but it's not the only thing, right? I think you are alluding more now to, right, what is more granular insights that we may get, right? Is this, I don't know, to your point, with these listings are performing better than these other listings? This is ultimately, giving the tip that we should be rebalancing our spend accordingly. So I would say that one thing is just the valuation of everything that we're doing, which is important when you compare versus other initiatives that there is in the company. The other one is within that initiative, which is within that marketing treatment, search in this example, what is the change in mixes that you can make, right? It could be audiences as well, right? Which are the audiences that are more prone to buy if they see some marketing impression.
Yes.
And then it is all this causality versus, which is very interesting, right? There is some tension, right, between propensity and causality, right? At times, the best customers who are the most prone to buy are actually the least incremental to marketing, because they are going to buy anyways. So maybe they don't need the help that we provide via search and via our partners such as Google, as much as other customers that unless they see us in the search result page, they wouldn't. So these are insights, to your point, that are coming from us, and these are more strategic kind of directions that we can help our partners in eBay, like marketers and financiers, when saying what else we can learn if you guys allow us the time, and if you guys can allow also the funds that are associated to any test, right? And that's probably the most beautiful part of the job is finding, how much more, so working on what we call the learning agendas, how much more we can learn if we set up tests even more smartly, right?
Super interesting. Yeah, I definitely want to ask you more about that. I want to ask you more about the so learning agendas, the platform itself. How do you look for things like saturation? If there's optimization sort of across the board. But before we jump into all that, I do want to remind the audience that we have the Q&A section available and open. So if you have any questions, put them in the Q&A section, and we'll go through those questions with Carlos as well. Anything you want to put on the chat as well, feel free to put any messages there, any feedback, anything that you're finding interesting, let us know. So Carlos, yeah, I wanted to ask you on the saturation question. That's so interesting, because obviously I think all the work that you do has such wide applicability and often in online, but also offline. And I think that the saturation question is an interesting one that when people are, or brands are opening stores in a city. It's how many stores is the right amount, locations. It's similar to a saturation question online.
Right.
How do you guys approach and address the saturation question?
So yeah, it's a good question. It's probably the key factor, right? Since spend is probably the main driver, how much spend is necessary, right? And I think the problem with this, as with any other example that you are raising, is just all the confounders that come with any change that you're making. So imagine that at some point, one thing that we do often is that we run longitudinal tests. So over time, we run different, spend levels or different features of our marketing work. But the problem with those is that you are changing over time. If anything is certain, is that there are more things changing, right? So well, imagine right now with the coronavirus and the certain in place policies, this is impacting e-commerce a lot. So you cannot compare any result in July with anything on May. Actually, not even 1 week versus the other, or depends on. So it is all about how to isolate things, and this is what makes experimentation. It's an interesting field where you need. It's a balancing act between rigor and perfection, and then actually, cost effectiveness, right? Because in order to be super precise academically, you will need to test every single hypothesis you have on an A/B basis every time that you want it. Now, to your point on saturation, such a problem as saturation, which is more of a continuous, right? It's not like two discrete positions, right? Do I prefer A or B? Well, I don't know. It's just the continuous of spend from 0 to whatever, right? Then how do you do that? And particularly on A, B, C, D, do you need to test like 1,000 different spend levels? So what we typically do is just you get into more A, B, C, D, multiple testing or multiple arms testing, where you do compare some specific critical points that you think are are some points where you will be able to interpolate after that, because they are close enough so that you would expect some kind of smooth progression, right, of return between one and the next. And with that comes a lot of business acumen and some of business sense and what makes sense on that. There are multiple choices that you make that are not necessarily scientific, because you will need to run another set of tests. You don't have time for that. So ultimately, it's this balancing act between, trying to be cautious with the amount of resources that you are putting into a test, and at the same time responding to the question with as many open possibilities as possible, right? You don't want to just constrain the response to an A or B answer, but trying also even to show, even to give the opportunity to the test setup to give some counterintuitive results. Like, for instance, if you think that the range of spend is between 3 points, then test another one pretty far ahead. See what happens. Maybe you're wrong. And then if you are wrong, then and you see that, I don't know, maybe return with this super high spend is much higher than what you expected, then that will trigger a new set of hypotheses to be tested. So it's this kind of a never-ending right quest for answering questions as much as raising new questions, and that we need just to set up every time that we run a test.
Yeah, for sure. So then how is that? Because each of the specific experiments, and it can be around saturation or the incrementality, the incremental return, maybe the alternatives for different products. So every experiment is so involved. I guess it needs as you said, like the learning outcomes, and it needs a good design. Then how does that go at scale? How did you move to a scalable experimentation platform? What are some of the components, and then of the platform, but also the culture, the mindset, the approaches to the work for people to be able to do this at scale? How was that journey?
Right. It is complex because I'll give you an example, right? At times you want scale, but at times actually opportunity comes from granularity, right? So let me give you an example. There are some marketing channels. I would say affiliate marketing. I don't know if everyone is familiar with that, but affiliate marketing is one where in e-commerce, we actually pay partners for traffic that they send to us, and we pay based on commission on sales. Now, as a result of that, we build these affiliate networks where you have thousands, literally thousands of partners, right? How would you measure this kind of channel, right? Do you want something scalable, as you say, or do you want something which is differentiated? Because actually the value that each of those is different. So the optimization opportunity comes from differentiation rather than scale. So that's one case, right, where differentiation matters a lot because you know for a fact that they are very different. On some other cases, it's more the other way around. So you are trying to find commonalities, so then you can coordinate some highly scaled, test. Now, I think it ultimately, depends on, in the e-commerce and digital marketing space. So there are by design, right? There are big platforms that are scaling by themselves. Like you have Google, you have paid search, particularly in Google, then you have Facebook, retargeting campaigns within those. So these companies, they try to organize their operations in a way that is already scaled, and then that is the level where we are running the tests. But as I was saying before, while that is one direction of the industry, then you will want the other one of differentiating a very diverse portfolio and running specific singular tests that will then be will allow you to have a differentiated lens on the portfolio. How to do that? To your question, yes, we build the experimentation platforms just to enable our partners, in the case of affiliate marketing, for instance, to enable our partners to run tests that are demanding from a technical perspective. So they need to be able to suppress ads to certain targets. They need to be able to identify users. They need to be able to randomize the audiences, things that for a medium-sized affiliate can be a little too complex, right, to run. So retailers like eBay, we do build these capabilities ad hoc based on the type of tests that we typically run. And I would say, to your point, in digital marketing, I just mentioned the three big factors that you need to take care of, right? One is identification of users. When I say identification, it's not that you need to know the name and certainly, but at least be able to identify distinct users and know when this user is coming back, so that he's always either in treatment or in control, but not swinging back and forth, because then it is diluting the signal. So identification, randomization, so making sure that the samples are randomized. So you are comparing, randomization is just the best friend of a statistician, right? Because then they are, particularly with the scale that we are working on in eBay, they are just naturally, by the law of the large numbers, they are naturally becoming comparable populations. And then suppression, right? Suppression, people in the audience may have heard about ghost ads, which is how typically all these A/B tests at the user level are called. What it means is that is this ability of just suppressing people that would be targeted, because that's the key, right? So you would have been targeted, but you haven't. And that's called this ghost ad technology. And these are the three. Once you have you master these three aspects: identification, randomization, and suppression, then you can run your test.
And this is incredible. To have the data at that scale, and the approach that you guys are taking is really Very impressive. Do you always prepare the test, the experiments proactively or ahead of time?
Sure.
And yeah, in our cases, are there cases where you can use the data from past experiments, or data that wasn't involved in experiments to be able to infer similar things that you would if you had run an experiment?
That's a great question. And actually, yeah, I think this is something that the industry is marching towards. So we come from an era of frequentism, right, where you're running a test, and a test is an entity of itself, right? So it provides an answer, yes or no. That's it. It doesn't communicate to other tests before or after, right? And so every time that we run a test was the ultimate test. Everything else before was not even accounted, which is, you know, from a conceptual standpoint, it was a little uncomfortable for many of us, because you say, well, we learned a lot in the past. Why would we just look at this just because it was the latest, right? It could be more contaminated. It could be, you know. And then what we are leveraging right now is frameworks such as Bayesian frameworks, where you borrow, what we call it like that, right? We borrow strength from history of tests in order to make a better estimate or a better read of the fresh read that you had on your latest test. And this is interesting. If you think about it, this helps in many regards, but I'm going to use one example. So one thing that happens every time in marketing experimentation is this noise or error, right? There is error because of the identification error, because of estimation error, because of volatility of the metric of interest, which typically is dollars, and that's a very, you know, very large, you know, very prone to outliers kind of metric, where some very big bias, even if you are capping or not, it is creating some noise around it. And then building on the distribution of events that you have collected over the past, it helps you identify outliers much better than if you are just you know, running a test as if it was the first and last test that you will ever run, right? So borrowing this strength from your history is helping us just to what we call shrink our estimators, which is basically having much more confidence on our estimates and having much narrower confidence intervals around those. And that's, I would say, I mean, for people interested in marketing analytics and the next evolutions of that, I think that's the next frontier. I think there are very few companies that are going that far, but actually that is what will bring, without necessarily testing more, is just a better use of your history of tests. You will just refine your findings and you just will get more competitive advantage, right, out of the experiments that you run.
Yeah, exactly. So the Bayesian approaches help organizations learn faster? Does that mean that the experiments would have either faster turnaround or require less data or a smaller population to get the same confidence? What are some of the other benefits? Sorry.
Right. So yes, could be. I think the greatest benefit is more about narrowing down the confidence intervals. So then you get to more precise. So let's say for a single readout, you will be more precise. On the other hand, because you get this tool or this method, right, which is allowing for further precision, it also allows for greater granularity, because there was some levels of grain, to your point before, on different types of listings or different categories, etc., right? That you could have made the split before, but you didn't have the statistical power, right, to run that. Now we're borrowing strength from multiple tests, then you can start finding some power in that. And what it means is that questions that before you couldn't answer, now you can. And when before you didn't know whether this vertical or this category is more incremental than this other, now you can say that. It's not that you are running more tests, it's just that you are leveraging the history of data that you didn't do before, right?
Yeah, exactly. This is really interesting, and it seems that in sort of in data science in general, there's at the moment it feels like there's a push for automation of creating machine learning models sort of automatically and at scale, and it feels like the causal inference approach unlocks so much more power, and it's something that requires. It feels like, and I want to get your thoughts on this. It requires a lot more, I guess, hands-on work, a lot more mental involvement,
Yeah.
deeper understanding of the techniques, and much more contextualizing in them, much more so they're used in a way that's appropriate for that specific use case. Is that the case?
So not so. I think the greatest difference that causal inference is bringing, and all these new branches that we are just glimpsing here, right? Like the Bayesian and these kind of things. Ultimately, the big difference that it makes for organization is that forces the organization to think probabilistically, which is a huge jump. So people, you need to think that, well, I'm talking to people with MBA degrees, right? These are the typical executives. And these guys, okay, yeah, they do have some idea of confidence intervals. But then when you get into probabilistic approaches, so they are very used to a black and white kind of indication, right? Is this better or worse? Then when you're saying, oh yeah, I'm 80% certain that it is better. What do you mean by 80%? Well, I mean exactly that. So that is harder, right? And then you have, okay, 80% sounds about right. But then, 60% doesn't sound right. Oh, 60% is true, is low, but the impact of this can be phenomenal.
Yes.
So would you just not do it just because of this 40% risk when the benefit is so phenomenal? So it gets into a very different kind of decision-making logic than the one that the organizations are used to. And that's super interesting, but it's hard. It is actually hard. And of course, in large corporations, you have multiple stakeholders. Not everyone is at the same readiness to take this on. And that's, I would say that's another, for future generations. I think that our generation will need to make advancement on that, but that is something for the years to come, right? Where we will see more and more organizations coming into how to intake, probabilistic inputs for the decision making.
Yes, definitely. And are there any resources that you could recommend on causal inference, experimentation, or the fusion of the Bayesian approaches into this space?
Sure. I think so. Well, let me just check it in a sec. There is one of the main resources. It's a little, I think like 10 years old or something. Is Efron's volume on large scale inference. It is actually not someone, so it's Efron is an academic, but he has been working on the pharmaceutical industry. Mm-hmm. And with but ultimately it is the same question that we are raising, right? The wealth of experimentation data that they have been collecting started pressuring on these this heuristic of just looking at the latest, right, rather than trying to borrow strength from the whole history. And he was the one, I think, bringing Bayesian approaches just to the mainstream in a way that I think in academia it is kind of becoming the mainstream, even though it is not fully. The Bayesian thing has some more or less controversial aspects, like there is some very subjective approach to Bayesian that Efron is not part of it. But I would recommend that book because it's a classic, for its own merits. Something more recent, than that is, and I know it has created a lot of attention, right? Is statistical rethinking. This is,
Yes.
you see,
Yeah.
yeah, this has been pretty popular, and I found it very, it's definitely very inspiring, and it is touching most of the questions, and with, I wouldn't say plain English exactly, but and it is full. It is full of examples, and actually it is working examples, like on R particularly, right? So if the audience, somebody is on R, he could or she could be following all the steps and chapters just with working examples of code, right? Which I think is fascinating, because one of the things on Bayesian is always how to make, you know, working models out of it, right? And then, yeah, statistical rethinking by McElraith. That's a very good volume, pretty recent.
That is awesome. That is fantastic. We'll definitely include those in the show notes. Great resources. And I wanted to ask you about I guess a slightly different case of experimentation, where you might not be able to withhold treatment.
Okay.
Maybe this is more from like healthcare examples, maybe pharmaceuticals, as you were saying, where there might be some health constraints or ethical constraints, where
Right.
if there's a treatment for somebody, that they should get it. Are there approaches in causal inference that can help create maybe like a retrospective control group of,
Sure.
and be able to compare the differences between them?
Right. So yes, right. It is all about understanding the population. I mean, understanding what I always say to the teams, right? You need to understand what you know and also what you don't know. So there will be limitations that you will know, like things that you don't know how to ascertain. Like, well, I know that I'm interested in this subset, and I know that if I look at this geographic location, I get more of this kind of people. But having said that, I don't know if as well there is a confounder, like, yeah, on top they are more prone to have this condition, you know, to an example of our own health. But I know as well that, or I don't know how much that condition is more severe than what it is present on others. So whatever is the situation, you will need to control for everything that you know and everything that you don't know. And that's, I think, the first exercise. Then in terms of how to set up that in retrospect, I think ultimately you will need to get to some hypothesis, which is, okay, I can make a divide, which is not perfect, between populations, but, you know, bear with me. Let's imagine that I can get to this perfect separation because of geolocation or whatever it is, which is not perfect, but it gives me some people much more exposed to that condition than this other group. Now, once you have that, and then you will want to run a test moving forward, but you will get into limitations of data, like one of the regions you had data historically, but you don't have data in the future. Then you get into opportunities around what we call synthetic controls, which is trying to build on the history and on the evolution of one of these groups, just to project what would be the normal performance, let me call it performance, or the normal behavior of the other population. So let's imagine let's put an example. So we have a sample of this region versus the sample on that region. Then you will be able to compare, starting from day one, the impact of giving a vaccine to one group versus the other. Now, okay, I can compare that, but I know that these two groups, they had different patterns of relationship in the past, right? So how can I see or how can I infer that whether they are closing the gap between themselves or they are enlarging, it is actually due to the different treatment, right? So that's more of, it is called as well the diff and diff, a kind of methodology where you are trying to measure whether the differences are actually closing or enlarging based on the historical data that you have. So then you build on the historical data, you run your synthetic controls, which is basically trying to predict based off, let's say, population B, what would have been population A if they would be staying with the same treatments. And then you compare that is a pure inference, right? You compare that inference with what happens actually with the population in A when you are making a completely different treatment, something that has never been exposed to it. That is what is closing gaps and what is closing comparisons, which is not apples to apples, right? It is populations versus two populations that have never been the same. What you are trying to see is whether the gap is widening or closing, right? So that's pretty, there are plenty of packages around that on, from multiple domains in marketing as well on how to run those with some robustness. And I would say, there are always, circumstances on whether, the history is exactly revealing of what the future will be. So whether this, choice that you made based off history and the relationship that they had in history are actually to be expected to have followed, or there is something that you have missed, which, just to close on that topic, will have to be solved by repetition of multiple tests, right? So you just you raised the point earlier on scaling tests. So instead of running a single test versus synthetic control, you just run many and then see, what is the smooth average of all those, just in order to get some greater confidence, right? And to avoid this kind of asymmetries that happen at times versus between past and future.
That is awesome. That is awesome, man. I'm enjoying this so much. We also got a message from Axel Ramirez. He said, "This business insight has made my morning." So thank you for that. I do. I know we're coming up on time, but I do have possibly a last question for you, Carlos. And I want to know, with everything that you've done in your career and in your work, I know that you also teach a lot, you mentor. What are you most proud of that you've done or accomplished in your career so far?
I will be very selfish on that. I would say two things. Just one very selfish, another one just to look a little nicer to you guys. The most selfish thing would be just learn, right? I think we are all of, I'm sure everybody listening to this, we are all learners, right? Lifelong learners, and we just enjoy learning. That's what actually triggers us, right? And I think that's something, right, immaterial. I cannot explain it. It probably doesn't make sense. It's just we love to learn, and having this, chance just to set up tests and get to learn more and get access to all this data just to learn more and more. I think that's what triggers us. And then the second point is on people, right? So when working on organizations, you always have opportunity, right? I always say this, right? I've been in academia, I've been in many places. I have to say that where I learned the most every time, it has been at work in industries, because there are so many smart people just looking at things differently with different backgrounds, etc. That is, I mean, from a selfish perspective, again, is where you get the most. So when you are the one giving, right, and you can see, like, you help somebody grow, or you help somebody start thinking differently about problems, that is also a very rewarding experience. So learning and people is probably the two answers.
Amazing. No, that is incredible. And I think that is a fantastic note to end on. And Carlos, I want to thank you so much for for your time, for sharing your experience, your knowledge, your insights, sharing part of all this learning that you've been doing over the years. Yeah, your experience is incredible, and the work that you've done is amazing. Definitely something that I see more, something that's more needed in data science as a field. And as you said, something that's definitely going to be more in demand and more popular in the future.
Yep.
Thank you so much for sharing that with us today.
Thank you, Felipe. Thank you very much, everyone. It was lots of fun. So I will keep following data futurology in the future.
Amazing. You take care. Stay safe. Everyone in the audience, take care. Hope to see you guys soon.
Okay, bye.
Thanks, everyone. Goodbye.